today's problem you take down, that is solve y double dash plus y dash minus 2y is equals to 0, where they have given the condition y of 0 it's equals to 4, y dash of 0 it's equals to 1. Now see in this question what they have given. They are asking you to, this as in first of all it's a homogeneous equation. Y double dash plus y dash minus 2y is equals to 0. Y of 0 is equals to 4. Y dash of 0 is equals to 1. So you are going to find the complementary function. Complementary function for the given differential equation. First of all, it is not in operator form. We will write it into the operator form. Your solution first will represent into operator form. That is d square plus d minus 2 of y it's equals to 0, where your d stands for differentiating with respect to x, dy by dx. Now we'll go for finding the auxiliary equation, your AE, where your d will get replaced with m square plus m minus 2 it's equals to 0, where your y cannot be equals to 0. So you are making your this differential equation by replacing your d with m terms, and it's equals to 0. How we can split this m into the common factors? Here we are having 2 and this 2. How we are going to write that one? Yes, Aditya, how you can represent this m in the common factors? Here we can solve by using the common factors.
2m minus m.
Yes, 2m minus m we can write. Good. M square.
2m minus m.
Yes, m square plus 2m minus m minus 2 it's equals to 0. From the first two term we can take m as common. M of m plus 2. Then from next we can take minus 1 as common. M plus 2 it's equals to 0. From this two term m plus 2 is common. M minus 1 then into m plus 2 it's equals to 0, where m is equals to m minus 1 is equals to 0 or m plus 2 is equals to 0. M is equals to 1 or m is equals to minus 2. Therefore, you got your values is equals to m is equals to 1 and m is equals to minus 2. So, the roots are, which roots they are? The roots are?
Real and distinct.
Yes, real and distinct, where your complementary function will be c1 e to the power of m1x plus c2 e to the power of m2x. This will be your general solution for complementary function. Your y is equals to c1 e to the power of x then plus c2 e to the power of minus 2x. They have given you the initial conditions, where your initial conditions what they have given, y is equals to 0, it's equals to 4. That means what? Your x is equals to 0 and y value is equals to 4. y dash is equals to 0, then your y is equals to 1. That means your x is equals to 0, y dash is equals to 1. So we'll make this equation as our equation number 1. There are two conditions is given. One it is for normal y and one more it's for y dash is z. So we are going to differentiate this equation number 1 with respect to x. Differentiating equation 1 with respect to x. So we'll get y dash is equals to C1, it's a constant. Next, e power x differentiation, it's equals to e power x. So C1 e power x. Your differentiation, where your e2 is a constant. E to the power of minus 2x is there. That differentiation is equals to minus 2 e to the power of minus 2x. So we can write minus 2 into C2 e to the power of minus 2x. Make this is equals to your equation number 2, where given initial conditions, given initial condition y of y of 0 it's equals to 4. That means this value stands for x and this value stands for y. Next condition they have given y dash of 0 value is equals to 1 they have given. That means this value for x and this value for your y dash. So Aditya, this condition will be applicable to which equation? Your first initial conditions where you are going to do the substitution to which equation? Equation 1 or equation number 2?
Um, 2.
For which equation you are going to apply this equation? These values?
2.
No. For to equation number 1, see here what they have given. Y of 0 is equals to 4 itself. So this condition it's applicable to this one. You are going to apply to this equation, and where your this condition is going to be applicable to the second equation. Y dash is there. This is your y dash and this is your y. So it's as an equation number of 1. Atman. Applying first condition to equation number 1. Equation number 1, that is 4, it's equals to C1 e to the power of 0 plus 2 is not there, C2 it's there, no? 0x plus C2 e to the power of what I am writing. 1 into 0, then this will be e to the power of 2 into 0. Something to the power of 0 is equals to what? Yes, Aditya. Something to the power of 0 is equals to?
One. One
It's
more.
1. So what we
One.
got that equation? 4 it's equals to C1 plus C2. Now applying second condition. Now applying second condition to equation number 2. What they have given that second condition? That your y dash value is equals to 1 when x is equals to 0. That you're going to get 1 it's equals to where your c1 e to the power of 0 into x minus 2 c2 e to the power of 2 into 0 into x. That is equals to 1 is equals to c1 minus 2 c2. That is your equation number B. Now what we are going to do? We are going to solve A and B for the constant values. Solving equation A and B, where that is equals to 4, it's equals to C1 plus C2, 1, it's equals to C1 minus 2 C2. This will be minus, this will be minus, and this is going to be plus. So this plus minus will get cancelled. Plus C1 minus C1. From here 3 minus 1, sorry 4 minus 1, it's equals to 3. Then this is equals to 3 C2. Where 3 and 3 will get cancelled. C2 is equals to 1. So we got one constant value. This one constant value will substitute into equation number 1. Substitute C2 value in any one equation. Either it will be in A equation or as a B equation. In any one equation we can substitute. So I will substitute in equation number A. Substitute C2 value in equation A. That is your 4. It's equals to C1 plus 1. Now take this of 1 on this side. So C1 it's equals to 4 minus 1. C1 it's equals to 3. Now we got that constant values. C1 is equals to 3. C2 is equals to 1. These values you have to substitute into your general equations where you have made that is equals to your equation number 1. Here you have to replace. You're going to substitute your C1 and C2 value into the where you have done the general solution. Here you're going to substitute. Substituting C1 and the C2 values in equation number 1. What was that equation number 1? Your y it's equals to C1 it's equals to 1 e to the power of x, then plus C2 value is equals to, I have written the wrong values. Here it should be as in a 3.
3 e raised to power x.
Yeah, 3 e power x, then plus here it should be 1 e to the power of 2x, which is your required solution. Which is the required solution. Any doubt, Aditya, here?
No, ma'am.
Little bit louder, Aditya. I'm not getting. The problem is clear. Or shall I repeat once
No,
again
ma'am.
this one explanation?
Yes, ma'am.
You want me to repeat? Do you need the explanation once
No, ma'am.
again, or shall I move
No,
to the next problem?
ma'am, like, how did you get the operator form? That's where I'm confused. The operator form.
This operator form, this is this what it's given here, y double dash plus y dash minus circle 2y, right? This means what? Y double dash means what? Y double dash means what? That is your d square y by dx square. This is your d square value, where your dy by dx, it's equals to d. Sorry, here it should be y should be there. What we are doing, we are writing in this form, d is equals to d by dx. So your d square, it's equals to d square by dx square, and d is equals to d by dx. So y completely you are writing here, you see, completely you are writing over here, outside you are writing, you are taking as a common from there, d square. When you are going to represent this one into your differential equation form, how you are going to write this one, I will show you it. Where your d stands for d by dx. D square y by dx square plus
Yes,
dy
ma'am. Got it, ma'am.
by
Got it, ma'am. Got it,
dx
ma'am.
minus 2y, it's equals to 0. Then later it will be d by dx, sorry, d square by dx square plus d by dx minus 2 of y, it's equals to 0. Now you can replace this d square by dx square, it's equals to d square plus d minus 2 of y, it's equals to 0. In this way you are going to represent. Is that clear? Yes, Aditya, is that clear?
Yes, ma'am. Yes, ma'am. Yes, ma'am.